Welcome to COP1000C. We're here at Valencia College. My office is on the East Campus, and the name of this course is Introduction to Programming Concepts. This class is going to teach basic computer programming fundamentals. The class will teach concepts regardless of a programming language. So the concepts taught in this class will not be programming language dependent. The class will use the C programming language to demonstrate the understanding of these programming techniques, but again, the techniques covered in the course can be used in any programming language. Main topics will be software development life cycle. Software development life cycle. So the software development life cycle is from the beginning to the end and back again. So basically how software is developed, maintained. It is cyclical. We do some research, we find out what type of software is needed, we spend time developing, we employ it, and we cycle back around. In this course we're going to teach good programming design. We're going to teach something called top-down programming. We're going to learn or cover variables and constants. The next major topic will be something called selection and decision, followed by repetition, followed by functions or arrays. Some instructors like to flip these two and do arrays before functions. Either way, these are the main topics for this course. Little statement here about my online students. Online students require the student to be very disciplined. Online courses require the student to be very disciplined. The online student needs to work harder and longer than a traditional on-site. The myth is you have to work less than on-site. That is not true. Online students must learn material on their own. They're going to have to watch videos. When I say watch the videos, I mean do the videos. So you're going to see examples in the videos. You should actually be typing them into your IDE and running them. So not only will these students have to watch videos, they're going to have to read the book, they're going to have to search the Google for different solutions. Online students have to be self-motivated. The instructor is there to answer questions, provide feedback, and to be available during office hours for one-on-one interaction. Other than that, the instructor is not participating in this course. So the instructor is going to grade your assignments, give you feedback, give you direction, be available in case you need them. Online students will fail due to lack of effort. An online student or you must put in the time. If you don't put in the time, you're going to fail. The failure rate for online students is they just don't put in the hours needed. Next is mixed mode students. Mixed mode students. Mixed mode class. Mixed mode classes are taught. Should be S's, are taught half on-site and half online. The online part of the mixed mode course requires a student to work harder and longer than a traditional on-site student. So half of the class is taught on-site and the other half is online. So this online portion requires a student to work harder and longer than a traditional on-site course. During the half on-site, the instructor is going to produce or present material and topics during this part. The students are going to still be required to learn the material on their own. They will have to watch the videos, do them, read the book, and search Google. So this half of the course, the student still has to teach themselves. Mixed mode students have to be self-motivated. Mixed mode students will fail because they treat the course like an on-site class. This is not an on-site class. It is mixed mode. The course requires the student to learn on their own. You need to spend a considerable amount of time online watching and doing videos. In COP1000, computer programming is the topic, and computer programming is based on mathematics. Computer program is based heavily on algebra. So my statement is, hopefully you like mathematics, you like algebra. If you do, you'll probably like programming. Now this is not a rule, but kind of basically true. If you're not strong in math, then you will not be strong in programming. If you are strong in math, then you will be strong in programming. Again, not a rule, just something I've observed over the years. In this course, COP1000, a student's going to be required to write somewhere between 10 and 15 programs. If you do not write these programs on your own, you will not pass the exams. It is easy to cheat and have people write programs for you. You'd only be cheating yourself. If you do not write the programs, you will not learn the material and you will not pass the exams. If you don't understand the programs you write, you will not pass the exams. Sometimes you write a program, but you still don't understand what you just did. Not only do you need to write it, but you need to understand what you wrote, the how, where, and why of what you just did. And as long as you do, you'll pass the exams. Otherwise, you will not. If you cheat writing the programs, you will not pass. If you write the programs on your own, and if you understand what you write, then you should do well on any exam. In this class, you will be taught programming concepts. On your own, you will need to figure out how to use these tools and concepts in order to write a program. So in this class, you're going to be taught a series of different tools, kind of like a carpenter learns how to use various tools to build a house. And then on their own, they take a set of blueprints and they would use these tools to build a program or a house in this case. Okay, in order to pass this class, you must think, plan, and act. Think, plan, and act. When writing a program, you would invent your own solution or your own version of a solution, which is kind of cool. You're inventing something each time. Hopefully programming is fun. If you invent your own solutions, if you design your own solutions, if you write your own code, if you test and design your code, if you understand what you're writing, then you should have fun and enjoy programming. So programming should be fun, and if you're not having fun, then something is wrong. Maybe it's not for you. Invent your own solutions, design your own solutions, write your own code, test and debug, understand what you wrote, and have some fun. If you're not having fun, then you may not cut out to be a programmer. Kind of simple as that. Not everybody gets to do everything. Maybe it's not meant for you. Hey, that's okay. We're not all meant to do the same thing. If you learn that you're not a programmer, guess what? You did learn something. If you're not having fun, you should probably consider a different field of study. Again, programmers enjoy programming. Anyway, welcome to the class. I would say relax and listen. Practice, ask questions, study, play around, enjoy the ride. See ya in the next video.